on Friday. He's on top of it.
All right.
He was on top.
So there was some important information from our notes. And what is it? It helps us make our chart.
The base.
And the base is what? 5. This problem is a 5. The base is the number that has the exponent. The number at the end is important, though. Do you remember what the number at the end does?
Makes it go up.
It's the horizontal asymptote. So you're right, the number on the end is important. It's just a different important thing, yeah. So here in the instructions, they said identify the rate of change, which is the exact same thing as identifying the base. They just called it something different this time. Okay, so the rate of change was 5, which is also the base. So we have the point 0.0115, then we know that our horizontal asymptote is normally at 0, but it can move, and it does in this problem. All right, so what is another transformation we have?
Stretch of 2.
Stretch of 2. So vertical stretch of 2. What do we do to the points? Okay, multiply both of them? The y coordinate. Okay, so that's going to be 0, 2, 1, 10. If you take a horizontal line and you stretch it by 2, does it change? No, it's just a line. It changes when you shift up and down. Yeah. All right, what's the next transformation?
Right 4, up 3.
Right 4, and then up 3. All right, so to go right 4, 0, 2 is going to change. What's the x coordinate going to be? 4, positive 4 because it went to the right. What's the next x coordinate? 5 because it went to the right. A horizontal line, when you move it to the right 4, it's still a horizontal line. It hasn't moved. And then when we go up 3, 2 is going to become, and 10 is going to become, and a horizontal line, when you shift up, is going to be 3. Yep. Horizontal asymptote. Ha! Get it?
No, because you can remember because the H-A-Y spells hay. And then
Oh, hey! But what does vaccine have to do with VAX? But how does that tell you?
I don't know, because the V-A-Y and like H-A-X, like
Vax. Oh, I got it. Vaccine. If we spelled vaccine wrong, because we know it doesn't have an X in it, technically. Okay, all right. All right, there's our horizontal asymptote, and we have the point 4, 5, and then 5, 10, 11, 12, 13. Miss Rice. Sorry, guys. It was an accident. Okay. Can somebody tell me what the domain is? Yeah. Go. No, but I'm just making sure that we know it. Yeah, it goes left forever, it goes right forever. Negative infinity to positive. What's the range? 3 to infinity. Sorry. Oh, that's getting real bright. Is this graph increasing or decreasing? Increasing. So for decreasing interval, we would say none. For increasing interval, what would we say? Negative infinity to infinity, because we're going left to right, right? So left arrow to right arrow. If we wanted to know if it's continuous, we would say yes, we can trace it, all right? If we wanted to know the end behavior, we would say as you look left forever, the y value is going to 3. As you look right forever, the y value is going to infinity. How would we find x-intercept? You wouldn't, but if we could, how would we? put it in your graphing calculator. What about a y-intercept? Put it in your calculator. Does it have a max or a min? No. Okay. So I think those are all the things I ask you to find. Let me look. So on the front page, as you can see, it only wants you to find the rate of change and the transformations so that you can graph it by hand. You should not be using a calculator for the first page. For the second page, it asks you to graph it still, but it's going to ask you to do it in a calculator to save some time and find domain and range and increasing and decreasing intervals. So we'll pay attention to the instructions when we do these ones. On the next page, then it narrows it down a little bit more. So just find the x and the y intercepts, just find the horizontal asymptote and the range. Do you technically need a calculator for 11 and 12? No. It makes it, you have to think a little bit harder if you don't use a calculator, but you can do it. Identify the growth rate. What do they mean when they say growth rate? The base, yep. And then the transformations, all right, so we can do that. And then it gives you one and asks you to find like all the things for it, basically. And then, ooh, what's back here? Oh, shoot, son. Those are piecewise functions. Woo! Woo! No, I didn't say we were done with it forever. Yeah. No, but not. Have you noticed? Have you noticed in this class that hasn't happened? Everything comes back. It all comes back.
It comes back to haunt you.
It's like I want to truly prepare you. Interesting. Interesting. Now, but the nice thing is it does say using a calculator. There is a typo here. This x, go ahead and scribble that out. That makes this a crazy function. I wanted it to be 5. Those buttons are right next to each other. All right, so we're changing that to a 5. And then down here, look at this craziness. Oh, it's asking you to plug numbers into the piecewise functions. Oh my goodness. And then look down here, it's our favorite. We love comparing functions. What a wonderful last page. So, yeah, if I was you, if I was you, I would maybe do the problems at the beginning, maybe spend like a little bit, make sure I'm comfortable, and then I'd go straight for that back page to finish it. I'd go straight for that back page to like get it done while I was in class. You know what I'm saying? Because that's clearly that's the hardest page. All of the pages are in the back already. All of them are done already, okay? But if I was you, once my brain was warmed up and I was feeling comfortable, like I kind of get these, I'd go straight for that back page because that's the hardest page. Then you can do the rest of it and get a 7 out of 10 on your assignment and potentially bomb that part of the quiz and test. So it's up to you. Okay. No, he was just saying what happens if he never did that page. Yeah. It just never happens. Yeah. Yes. Right.
Oh, okay, thank you.
Right here. Change the x to a 5.